One problem is there. Third problem. Two stars, each are mass m, radius r, are approaching each other for head-on collision. They start approaching each other when their separation is r. R is much greater than capital R. Mean capital R is negligible comparison to small r. When they have started, their speeds at that separation is 0. Correct. The speed v with which they collide each other. With which they collide each other. They have given 4 options. See here. When they are at large distance comparison to r. That time what happened? Their speeds are negligible. Okay. What will be the velocity when they will collide? When they will collide each other, what will be the velocity? Okay. They want velocity. So see. We can apply here law of conservation of energy. That time velocity is negligible, mean velocity is 0. What will be the potential energy? And that time what will be the potential energy? And the velocity here, velocity is v. So law of conservation of energy, we can apply here law of conservation of energy. So this time what will be the total energy, and this time potential energy, total energy at time of collision is equal to total energy at the separation, total energy at distance is smaller. The potential energy plus kinetic energy at time of collision is equal to potential plus kinetic at distance r. Here, what will be the potential energy? Total distance between the center is 2r. So you can write here minus gm into m upon what happened? Mass is m, radius is r. The distance between them is 2r. Gm into m upon 2r plus kinetic energy. Kinetic energy of them is half mv square first plus half mv square second. This would be the kinetic energy of both. Potential energy plus kinetic energy at the distance r. Here velocity is negligible at that time. What will be the potential energy? The distance between them, when they start approaching, separation is r. What will be the potential energy at that time? So minus gm into m upon separation between them, that is smaller. And kinetic energy v is negligible, that time is 0. Here half mv square, mv square is equal to what? This will take right. So minus becomes plus, so gm into m upon 2r minus gm into m upon r. 1 m cancel out, so v square is equal to what? Gm. You will take common, so remaining is what? 1 upon 2r minus 1 upon r. 1 m we have cancelled out, so v is equal to under root Gm 1 upon 2r minus. So see here, what we have applied at the time of separation, R, what will be the total potential energy and total kinetic energy, total energy, and when the separation is when they will collide, that time what will be the potential energy. See here, for potential energy you have to take distance from center to center. So here center to center, what will be the distance? So that whole distance becomes 2r. So that's why potential energy is minus Gm into m upon 2r. So by law of conservation of energy, we can find velocity Gm 1 upon 2r minus 1 upon r. So B option will be the correct option. And here one problem is there. A block of mass m kept on a horizontal platform accelerating A with acceleration A during time interval t. The work done by normal reaction between the block and platform. Between block and platform, what will be the normal reaction? Work done by that normal reaction. 4 options they have given. First is mg a t square upon 2, half mg plus a t square, half ma square t, and 0. See, they want normal reaction, force by normal reaction. To see weight mg will act downward, normal reaction act upward. See, these are acceleration. To see accelerated frame of reference, we have to consider pseudo force. So one pseudo force will act. So that is pseudo force. So that pseudo force. So that will equal to what? M into A. Accelerated upward, so pseudo force will act downward. So pseudo force is equal to how much? That is pseudo force is equal to M into A. If acceleration upward, so pseudo force will act downward. So what will be the normal reaction? So normal reaction is equal to what? Normal reaction N is equal to what? Mg plus Ma. So that is Mg plus A. So this will be the normal reaction. And direction of normal reaction is upward. And see here, acceleration is also upward, so displacement will be also upward, so displacement and normal reaction both have same direction. So what will be the displacement in time interval t? Acceleration is a starting from initially 0, so what will be the displacement? Displacement in time interval t. So S is equal to ut plus half at square. So this will be the displacement. So what will be the work done? Because constant force, normal force is acting, normal reaction is acting, so work done is equal to what? And direction is also normal reaction and displacement both have same direction. That's why directly we can write work done is equal to constant force into displacement. The force is mg plus A into displacement is half at square. So which option will be correct? B option will be the correct option, half mg plus A into a t square. B option will be the correct option. I am going to discuss question number 3. A large number of water, each of radius small r, combine to have a drop of radius capital R. If the surface tension is T and mechanical equivalent heat is J, then rise in temperature. Actually, we can use direct formula also here. What are the rise in temperature? Del theta is equal to what? 3T upon equivalent, mechanical equivalent J C D density 1 upon R minus 1 upon R. This is the formula for rise in temperature. You can see here C is specific heat, specific heat of water. For water C is equal to 1, density also we have to take 1. So this formula becomes del theta is equal to 3T upon J C1 D1 1 upon R minus 1 upon R. So this is the change in temperature, rise in temperature. So we can see here option C is correct. Okay, how this formula has come? So you have to remember something. Firstly, suppose R, combined they are marking, suppose n large number, n number combining, there is n drops, radius R, they are combining capital R, volume of n drop is equal to volume of single drop after combination. Here we can see what is the relation between n and R. So n is equal to R cube upon R cube. So this is the relation between n and R. What will be the work done or energy? Okay. Work done, we know work done is equal to surface tension into increase in area. What will be the increase in area? See here, change in area. So initially n drop is there and each has area 4 pi r square. After combining, area becomes 4 pi single drop. This will be, if we take common 4 pi T n, 4 pi I have taken common. If I have written n as r cube upon r cube, r square, this is r square. So here T, if r cube I have taken common, r square cancel as a r cube I have taken common, 1 upon r. So this will be the work done formula. 4 pi r cube T 1 upon r minus 1 upon r. This will be the formula for work done. So you can remember directly 4 pi r cube T 1 upon r minus 1 upon r. Okay. So this work done convert in the form of heat. Okay. So that work done is equal to what? Q. What do we know? Change in temperature. Q mean MC change in temperature del theta. So here del theta is equal to what? So del theta is equal to work done upon MC, mean T 4 pi r cube 1 upon r minus 1 upon r divided by MC. See here, M, mass. Mass is equal to क्या होता है बेटा? Volume into density. The volume is equal to what? Big drop, that is 4 by 3 pi r cube into density. Density is D. So 4 pi cancel, r cube cancel, 3, it will come 3D upon dc 1 upon r. One thing more, if we convert, this is in joule form, so joule converted into calorie form, so this is divided by J. So J we will divide when we will convert into calorie form, the MC delta theta. So here J will be there. Okay, so this is the increase in temperature 3T upon JDC 1 upon R minus 1 upon R. In this here, one thing you have to know, work done formula is what? T into 4 pi r cube upon r minus r square, or in this form you can remember T 4 pi r cube 1 upon r minus 1 upon r joule. If you want to convert calorie, divided by J, that much calorie. Okay, this is calorie. So Q is equal to mc delta theta, to change in temperature. So this C option will be correct. Question is there. Three charges are placed at the vertices of a equilateral triangle. Side A. Here plus Q, here minus Q charge. Correct the force experienced by charge placed at vertex A. At vertex A, plus Q charge is there. What is the force experienced by this charge? In a direction normal to BC. See, this is this. In a direction normal to BC. To C, positive charge, they will apply the force, repulsion force. Suppose this is F1. Here plus and minus Q. So their attraction force, direction of force. Okay. If you see magnitude of these forces, F1 is equal to what? 1 upon 4 pi epsilon naught Q upon side A square. Also you can see magnitude of this charge F2. This is also 1 upon 4 pi epsilon naught Q upon A square. Mean F1 and F2 both magnitude is same. Here suppose I have written plus Q charge here. If you see F1 has component, this angle is 60, so this angle is 60. This is F1 cos 60, same way here F2 cos 60. Here F1 sin 60 components, here F2 sin 60. If we'll see perpendicular to the force experienced by charge along BC, the force experienced by charge plus Q at A. What they have said, the force experienced by charge placed at vertex A in direction normal to BC. Normal to BC mean along vertical, this direction. Normal to BC. So F1 sin 60 minus F2 sin 60, and F1 F2 both have same magnitude. So this means they will cancel each other. F1 sin 60 minus F1 sin 60. Result is 0. So if you ask the force perpendicular or normal to BC, along normal to BC, so the correct answer will be what? 0. If they have asked net force on plus Q, the net force will be what? If they have asked net force, F1 sin 60 and F2 sin 60 will cancel. The net force is actually F2 cos 60 plus F1 cos 60 along CB. F2 F1, this is 1 upon 4 pi epsilon naught Q square upon A square cos 60 1 by 2, and this is also 1 by 2. So this becomes twice of this. Twice of this mean 2 cancel out. 1 upon 4 pi epsilon naught Q square upon A square, and direction will be along CB. The actual net force is that, but direction is along CB. They want normal to the CB, that option is 0. If they have asked net force on plus Q charge, so that is 1 upon 4 pi epsilon naught Q square upon A square along CB. Because F2 and F1 both have magnitude this, So cos 61 by 2, so this is twice 2 cancel. This will be the force, net force upon charge plus Q at point A. A very interesting question. Axis of solid cylinder in finite length and radius r lies along y-axis. It carries a uniformly distributed current I along plus y direction. Magnetic field at a point r by 2, y r by 2. Very interesting question. Cylinder is there. Cylinder is along y-axis, uniformly distributed. Current I, main current per unit area, you can say I upon 4 pi r square, because radius of the cylinder they have given r. Suppose this is x-axis, this is suppose y-axis, or here what I have supposed this board, planar board is xz axis and y-axis is perpendicular to this. To see here, x-axis, this is y-axis and this is z-axis. So y-axis I have taken perpendicular to this. So I have made this cylindrical wire fully. This solid cylinder is there. Okay. Current distributed all over. Current I, uniformly distributed current I all over the area. So what will be the current density? So current density to current per unit area is pi r square. So what they have seen? R by 2, y r by 2. At this point, what will be the magnetic field? So see here, xy, so this is r and r. So this point is r. Because current is parallel to along the plus y direction, it is independent of y. So that's why y I have not considered. Only I have taken the point at xz plane. So what will be the distance from center? The distance from center, this is r. So this becomes r by 2 point is there. So this becomes r upon root 2. So see here, this is the point where we have to find the magnetic field. Suppose I am make this circle and I am going to apply here Ampere's circuit law. So Ampere's circuit law, what they are saying, B dl dot dl is equal to mu naught total current included by this area. Suppose this is I dash. What will be the I dash? I dash is equal to what? Current density multiplied by area of this. The area of this will be pi, radius is r upon root 2 square, r square upon 2 cancel. So current enclosed by this area, this in within Ampere's loop. So this will be I upon 2. So B dot dl and B parallel to each other. So what will be the direction of? So here we can see this is positive y-axis. So direction will be here we can show the direction. So direction will be this, tangential to this. So this will be the direction of B. In magnetic field, direction of magnetic field will be along the tangential of this circle. Radius of circle is r upon root 2. So we will find the direction. B and dl both are parallel to each other. That's why B dot dl only bl. B integration of dl for this, that is 2 pi. Radius of this is r upon root 2 is equal to mu naught total I. Total current enclosed by this circle, that is I have here founded I upon 2. So B is equal to mu naught I upon 2 root 2, here 2 pi r, this is mu naught I root 2 upon 4 pi r. So this will be the magnitude of magnetic field at position r by 2, y r by 2. It is independent of y, that's why I have taken only xz plane and considered r by 2 point and r by 2. The distance from center, that way becomes r upon root 2. So what will be the direction here? So here we can see, if you are breaking this direction along x-axis, positive along x-axis and along z-axis, what will be the direction? 45 degree. You can see here, and this is downward. So what will be the direction of B? See here, what will be the component along x-axis? I cos 45, and along z-axis this is but negative direction. So what will be the direction? Positive of y-axis and negative of z-axis. And cos 45 mean, you can say here cos 45, so direction is I minus j upon the direction of B. This also you can see from here, this is the direction of B. So direction of B is what? Positive I upon root 2 minus unit vector, if you say to I minus j upon root 2. So this will be the direction and this will be the magnitude. What will be the B multiplied by this? So mu naught I root 2 upon 4 pi r multiplied by I minus j upon root 2, root 2 cancel. So mu naught I upon 4 pi r I minus, sorry, this direction is downward is k. Negative direction of z-axis, that is downward. This is k, minus k. So I minus k. So mu naught I upon 4 pi r I minus k. The first option is correct. फिर से एक बार ध्यान से सुने. This I have taken as cylinder, solid cylinder. Current is flowing along the positive direction of y-axis. How we are giving the magnitude and direction? The direction is given by right hand thumb rule. Thumb will be along the positive direction, so this will be along tangential. This will be the direction of B. First thing, and what will be the magnitude? The magnitude we are finding by Ampere circuit law. I have make a empirical loop. ठीक है? So this empirical loop I have formed. The point is what? R by 2, R by 2. So R by 2 along plane XZ I have taken this. ठीक है? So this is R upon root 2 radius 1 empirical circle I have drawn and applied. B dot dl is equal to mu naught. Current enclosed by this circle. So remember, this will be cross section of current element I have taken. Remember, if you will take cross section, it will be very easy. So this I have found it by Ampere circuit law. And magnitude and direction is given by this vector, the B. So this will be the I minus negative direction of k and positive direction of x-axis, I minus k upon root 2 unit vector along this and multiplied, so this will be the vector B. Suppose if current I is along negative direction of y-axis, तो this will be the reverse. तो वहाँ पर क्या होता है बच्चों? This will be, तो ये क्या होता है upward. तो वहाँ पर what happen? This upward mean ये आपका क्या हो जाता है बेटा? Plus of k and minus of I. तो वहाँ पर k minus क्या होता है? I cap. लेकिन अगर क्या होता है बेटा? Current I along minus y direction. यहाँ plus y direction they have given. तो current direction of current will be I cos 45 minus k cos 45. or you can say I minus k upon root 2. The A option will be the correct option.